Welcome to Confined Space Entry Training at Nature Rich Labs. This training is designed to ensure the safety of all employees who may work in or around confined spaces. Understanding the hazards, entry procedures, and safety protocols is critical in preventing accidents and ensuring compliance with workplace safety regulations. Let's get started. In this section, we're going to define what a confined space is and why it's important to recognize these areas before working in or around them. A confined space is any area that meets three key criteria. First, it's large enough for a person to enter and perform work. This means you can physically fit inside the space to do a task. Second, it has limited or restricted entry or exit. This could mean a small opening, a narrow passageway, or the need for special equipment like a ladder to enter or leave safely. And third, it is not designed for continuous occupancy. In other words, the space wasn't built for people to stay in for long periods. It likely lacks proper ventilation, lighting, or other necessary conditions for safe, extended work. Now, not all confined spaces are the same. Some pose additional dangers, making them permit-required confined spaces, or PRCS. These are spaces that contain a hazardous atmosphere like toxic gases or low oxygen levels, materials that could engulf a worker such as water, grain, or sand, walls that taper inward or floors that slope downward, increasing the risk of entrapment or suffocation. Any other serious hazard like extreme temperatures, moving machinery, or electrical risks. To put this in perspective, some common examples of confined spaces include storage tanks, boilers, manholes, silos, pits, tunnels, and even certain crawl spaces. Recognizing a confined space and understanding whether a permit is required before entry is critical for your safety. Always follow proper procedures and never enter a confined space without proper training and authorization. Next, we'll go over the hazards associated with confined spaces and how we can control those risks. Now let's talk about one of the most dangerous risks in confined spaces: atmospheric hazards. Confined spaces can contain hazardous atmospheres that can displace oxygen, cause poisoning, or create a risk of fire or explosion. If these hazards go undetected, they can lead to serious injury or even death in just a matter of minutes. Here are the most common atmospheric hazards you need to be aware of. Oxygen deficiency. When oxygen levels drop below 19.5%, it can cause dizziness, confusion, unconsciousness, and in severe cases, death. Oxygen enrichment. On the other hand, too much oxygen levels above 23.5% can increase the risk of fire and explosion, making even small sparks extremely dangerous. Toxic gases and vapors. Confined spaces can contain deadly gases like carbon monoxide, hydrogen sulfide, ammonia, or chemical fumes. These gases may have no odor, but they can cause poisoning, suffocation, or immediate health effects upon exposure. Flammable or explosive atmospheres. Gases like methane, gasoline vapors, or hydrogen can ignite in confined spaces. One small spark could trigger a fire or explosion, putting everyone at risk. So how do we control these hazards? Air monitoring. Before entering a confined space, always perform air testing to check oxygen levels and detect any toxic or flammable gases. Continuous monitoring should be done while work is in progress. Ventilation. If hazardous gases are detected, ventilation systems should be used to remove contaminants and maintain a safe atmosphere. Respiratory protection. When ventilation alone is not enough, workers must wear the proper respiratory protection to ensure they are not breathing in harmful substances. Bottom line: never assume a confined space is safe to enter. Always test the air, ventilate, and use proper protective equipment to keep yourself and your team safe. Another serious danger in confined spaces is engulfment hazards. These occur when a worker is trapped, buried, or suffocated by materials inside the space. Engulfment can happen suddenly and without warning, making it one of the deadliest risks in confined spaces. Here are some common examples of engulfment hazards. Flowing liquids, water, chemicals, or sludge can quickly fill a confined space, trapping a worker or causing drowning. Loose materials. Substances like grain, sand, sawdust, or powders can shift unexpectedly, collapsing around a worker and burying them completely. These materials behave like quicksand, making escape nearly impossible without assistance. How do we prevent engulfment hazards? Lockout tagout. Before anyone enters a confined space, all pumps, valves, and material flow systems must be locked out to prevent accidental releases. Harnesses and lifelines. Workers should always wear harnesses and lifelines so they can be quickly rescued if an engulfment occurs. Proper permits and supervision. Never enter a confined space alone. Entry should only be allowed with a permit, proper training, and a trained attendant monitoring from the outside. Bottom line, engulfment can happen in seconds. The best defense is prevention. By controlling material flow, using safety equipment, and ensuring proper supervision, we can protect workers from this deadly hazard. Another serious risk in confined spaces is entrapment and mechanical hazards. These dangers arise when tight spaces, moving parts, or unstable structures create a risk of trapping, crushing, or injuring workers. Common risks to watch for: sloped walls or funnel-shaped spaces. Some confined spaces, like silos or storage bins, have walls that slope inward. If a worker slips or falls, they can become trapped with no way to climb out. Machinery or rotating equipment. Some confined spaces contain mechanical parts that can start unexpectedly if they're not properly shut down, leading to serious injury or death. Unstable structures or falling objects. Loose materials, unsecured tools, or unstable surfaces can collapse or shift, pinning a worker inside. How do we control these hazards? De-energize and lockout tagout. Before anyone enters a confined space, all machinery and equipment must be completely shut off and locked out to prevent unexpected activation. Use fall protection. When working in vertical spaces or areas with entrapment risks, always use harnesses, lifelines, or guardrails to prevent falls and aid in rescues. Have an emergency escape plan. Workers should always have a clear escape route before entering a confined space. If an emergency occurs, rescue procedures must be in place to ensure a safe and quick exit. Bottom line: confined spaces can be unforgiving. Being aware of entrapment and mechanical hazards and following proper safety protocols can mean the difference between life and death. Always take preventative measures before entering. Now let's talk about physical hazards in confined spaces. Unlike atmospheric or mechanical hazards, these dangers directly impact the worker's body and can lead to serious injury if not properly managed. Common physical hazards to be aware of: extreme temperatures. Confined spaces can trap heat or cold, causing heat stress, cold stress, or burns from hot surfaces. Noise hazards. Sound echoes in confined spaces, making noise levels much higher than in open areas. Prolonged exposure can cause permanent hearing damage. Poor visibility. Many confined spaces have little to no lighting, which increases the risk of falls, missteps, or accidental contact with hazardous materials. Slips, trips, and falls. Wet, uneven, or obstructed flooring can turn a simple movement into a dangerous accident. How do we stay safe? Use proper PPE. Workers should wear the right protective equipment, including heat-resistant suits, hearing protection, and anti-slip footwear based on the hazards present. Ensure proper lighting. Portable mounted lights should be used to eliminate dark areas and help workers see their surroundings. Eliminate trip hazards. Before entering, remove obstacles, cables, or loose materials that could cause a fall. Where needed, install guardrails or barriers to prevent accidental slips. Bottom line: confined spaces often have hidden physical dangers that can be just as serious as toxic gases or machinery risks. Proper preparation, PPE, and hazard elimination are the keys to staying safe. One of the most dangerous risks in confined spaces is hazardous energy. Some confined spaces contain electrical, hydraulic, pneumatic, or chemical energy that, if unexpectedly activated, can cause serious injury or death. Common hazardous energy risks. Live electrical wiring. Exposed or faulty wiring in a confined space can create a risk of electrocution. Hydraulic or pneumatic pressure. Pressurized systems like valves, pipes, or cylinders can suddenly release energy, causing equipment to move unexpectedly and trap or crush workers. Chemical exposure. Leaks or spills of toxic, flammable, or corrosive chemicals can pose an immediate health risk, leading to burns, poisoning, or respiratory issues. How do we control these hazards? Lockout tagout. Before entering any confined space, all hazardous energy sources must be locked out and tagged to prevent accidental activation. Test and verify. Simply turning off equipment is not enough. Always verify that systems are completely de-energized before entry. Use proper PPE and emergency procedures. Workers should wear protective clothing, gloves, and respirators when dealing with chemical risks. Emergency decontamination stations should be readily available in case of exposure. Bottom line: hazardous energy is invisible but deadly. Following lockout-tagout procedures, testing systems, and using proper PPE can prevent fatal accidents in confined spaces. Confined spaces can also pose biological hazards, which may not always be visible but can have serious health effects. These hazards come from bacteria, mold, decomposing materials, and even animals or insects that thrive in enclosed environments. Common biological hazards to watch for: sewers or wastewater tanks. These spaces contain harmful bacteria and gases that can cause infections or respiratory issues. Decomposing materials. Organic matter breaking down can release toxic fumes that may be poisonous if inhaled. Insect or animal infestations. Rodents, insects, or even birds can introduce diseases through bites, stings, or contamination. How to stay safe. Wear protective gear. Always use gloves, masks, respirators, and full body suits when working in areas where biological hazards are present. Ensure proper ventilation and air testing. Confined spaces must be tested for airborne contaminants and properly ventilated to reduce exposure risks. Follow decontamination procedures. After working in a hazardous area, wash hands thoroughly, clean equipment, and decontaminate all surfaces to prevent spreading harmful substances. Final safety considerations. Before entering any confined space, always conduct a thorough hazard assessment. Make sure permits, monitoring, and emergency procedures are in place. No entry should occur unless all risks are identified and controlled. Bottom line: biological hazards may not always be obvious, but they can be just as dangerous as chemical or physical risks. Protect yourself, test the air, and follow proper safety procedures to minimize exposure. Confined space entry is strictly regulated to prevent accidents, injuries, and compliance violations. Every person involved in the process has specific responsibilities to ensure a safe work environment. 1. Entry supervisor. The entry supervisor is in charge of the overall safety of confined space operations. They determine if a confined space requires a permit due to hazards. Ensure that permits, safety measures, and proper PPE are in place before entry. Have the authority to suspend or cancel entry if conditions become unsafe. 2. Authorized entrant. Authorized entrants are the workers who enter the confined space. Their responsibilities include reviewing the entry permit and understanding all potential hazards, wearing all required PPE and continuously monitoring for signs of danger, maintaining constant communication with the attendant and exiting immediately if conditions change. 3. Attendant or whole watch. The attendant, also known as the whole watch, stays outside the confined space to ensure safety. They monitor entrance for distress and exposure to hazards, maintain continuous communication, and keep track of who is inside the space. Alert the entry supervisor and call for emergency rescue if needed. 4. Safety personnel or rescue team. The rescue team is trained to respond quickly in case of emergencies. They are certified in confined space rescue, CPR, and first aid. Stand by with retrieval and rescue equipment in case of an emergency. Respond immediately to incidents and follow decontamination procedures if necessary. Confined space entry permit is required for all permit-required confined spaces. This ensures that hazards are identified, safety measures are in place, and workers are protected before entry. 1. Pre-entry procedures. Before any work begins, the following steps must be completed. Hazard assessment. Identify any atmospheric, mechanical, or engulfment risks. Air monitoring. Test for oxygen levels, toxic gases, and flammable vapors to ensure a safe environment. Ventilation. If hazardous gases are present, mechanical ventilation must be used. Lockout-tagout. All energy sources must be de-energized to prevent accidental activation. PPE compliance. Workers must wear respirators, gloves, harnesses, and protective suits as needed. Communication plan. A clear method for entrants to communicate with the attendant must be established. Rescue plan. The emergency response team must be on standby and ready to act if needed. 2. Entry permit requirements. Before entry, a permit must be completed and approved, including date, location, and names of personnel involved. Identified hazards and required safety measures. Air monitoring results and PPE requirements. LOTO verification and emergency contact information. Signed approval from the entry supervisor. 3. Work execution and monitoring. Once entry begins, continuous monitoring and safe work practices are required. Entrants must continuously monitor air quality using gas detectors. The attendant remains on standby to track conditions and respond to emergencies. All tools and equipment must be properly grounded to prevent sparks and ignition hazards. Work must stop immediately if hazardous conditions arise. 4. Post-entry and permit closure. After work is complete, all personnel must exit safely. The entry supervisor reviews and secures the permit. Permit is officially closed and filed for record-keeping. Bottom line, a properly executed permit process ensures that confined space entry is done safely, with every risk accounted for and controlled. No one should enter a confined space without the proper permits, training, and emergency response measures in place. Proper training is critical for ensuring safe confined space entry. Employees must complete role-specific training to recognize hazards, follow safety procedures, and respond to emergencies effectively. 1. Types of training. To ensure safety, employees receive training based on their role. General awareness covers confined space identification, hazards, and basic safety procedures. Authorized entrant focus on hazard recognition, PPE use, communication, and emergency exit procedures. Attendant trains on monitoring entrants, maintaining communication, and initiating emergency response. Entry supervisor responsible for overseeing permits, conducting hazard assessments, and enforcing safety protocols. Rescue team specially trained in confined space rescue, retrieval, and emergency medical response. 2. Training requirements. Employees must complete training at specific intervals to ensure competency. Initial training required before any confined space work begins. Refresher training conducted annually or when hazards, procedures, or equipment change. Retraining required after an incident or non-compliance to reinforce safety procedures. 3. Hands-on training. Practical training ensures that employees can apply safety procedures effectively. Air monitoring and hazard detection using gas detectors to assess air quality. PPE use and fit testing, proper use of respirators, harnesses, and gloves. Emergency drills, simulated rescue and response scenarios to prepare for real-life situations. Lockout-tagout ensures employees can safely de-energize equipment before entry. 4. Documentation and compliance. All training is documented and retained to ensure regulatory compliance. Training records must include completion dates and employee roles, written tests and hands-on training evaluations, retraining logs for incidents or non-compliance. Contractors performing confined space work must follow all safety policies, permits, and regulations to ensure a safe working environment at Nature-Rich Labs. Compliance is critical to prevent accidents and maintain workplace safety. 1. Contractor responsibilities. All contractors must follow OSHA 29 CFR 1910.46 and Nature-Rich Labs confined space policies. 10. Safety orientation before beginning work. Provide proof of confined space training for all employees involved. Use proper PPE, air monitoring equipment, and lockout-tagout procedures to control hazards. Communicate with Nature-Rich Labs supervisors before entry to ensure all safety protocols are understood. Follow emergency and rescue procedures and be aware of the proper response actions. 2. Nature-Rich Labs responsibilities. Nature-Rich Labs ensures that all confined space work follows proper procedures by pre-work coordination, identifying permit-required confined spaces, and communicating all known hazards to the contractor. Permit and safety requirements. Verifying that contractors have the necessary training, PPE, and hazard controls in place before entry. Emergency readiness, ensuring that contractors understand and follow all rescue and decontamination procedures in case of an incident. 3. Communication and compliance. Contractors must meet with Nature Rich Labs safety personnel before work begins to review site-specific safety measures. All incidents, hazards, or changes in conditions must be reported immediately to supervisors. Unauthorized entry, unplanned rescues, or failure to comply with safety regulations may result in immediate removal from the site. 4. Post-work and permit closure. All personnel must exit the confined space safely, and the area must be returned to a safe condition. The entry supervisor must review and officially close the permit. Any incidents or near misses must be reported and documented for corrective action. Proper atmospheric testing is critical before and during confined space entry to detect hazardous conditions and ensure worker safety. This process helps prevent toxic exposure, oxygen deficiency, and fire or explosion risks. 1. Why is atmospheric testing required? Atmospheric testing is required to detect hazardous atmospheres before workers enter, prevent oxygen deficiency and exposure to toxic gases, ensure compliance with OSHA regulations, reduce fire and explosion risks by monitoring flammable vapors. 2. What hazards do we test for? Testing must identify oxygen deficiency. Levels below 19.5% can cause dizziness, confusion, and unconsciousness. Oxygen enrichment. Levels above 23.5% increase the risk of fire and explosions. Toxic gases, carbon monoxide and hydrogen sulfide are odorless but deadly. Flammable vapors, methane, gasoline vapors, and hydrogen can ignite or explode in confined spaces. 3. Testing procedures. Pre-entry testing. Air must be tested before any worker enters the confined space. Continuous monitoring. Testing must continue during work to detect changing conditions. Proper testing order. Oxygen levels first. Flammable gases next. Toxic gases last. Use a calibrated gas detector. Always ensure the device is tested and functioning before use. For what happens if the atmosphere is unsafe? Conditions are unsafe, do not enter. Ventilate the space until conditions are safe. Use respiratory protection if required. Retest the atmosphere before approving entry. 5. Documentation and compliance. All test results must be recorded in the confined space permit. Testing must be performed by trained and authorized personnel. Emergency procedures must be followed if hazardous conditions arise. Ensuring safe confined space entry requires strict control measures to eliminate risks, enforce safety procedures, and ensure compliance. By following these measures, we can prevent accidents and protect workers. 1. Hazard elimination and engineering controls. To remove or reduce hazards, we must use ventilation systems to remove toxic gases and maintain safe oxygen levels. Apply lockout/tagout to ensure equipment is fully de-energized before entry. Install barriers and guards around confined space openings to prevent falls and unauthorized entry. Use explosion-proof, non-sparking tools when working in flammable atmospheres. 2. Safety procedures and monitoring. Strict procedures must be followed to keep workers safe. Permit system. Permit required confined spaces must have formal approval before entry. Atmospheric testing. Air must be tested for oxygen levels, toxic gases, and flammable vapors before and during entry. Continuous monitoring. Air quality must be tracked throughout the work to detect any hazardous changes. Time limits. Workers should limit time inside confined spaces to reduce fatigue and exposure risks. 3. Personal protective equipment. PPE is required to protect workers in hazardous environments. Respiratory protection, used when oxygen levels are low or when hazardous gases are present. Fall protection, harnesses and retrieval systems are required for vertical entries. Chemical-resistant gear used when handling hazardous substances. Hearing and eye protection shields workers from loud noise and flying debris. 4. Communication and emergency response. Attendant monitoring. A trained attendant must remain outside at all times. Clear communication. Entrants must stay in constant contact with the attendant. Rescue team on standby. Trained responders must be ready to act immediately. Non-entry rescue. Tripods, winches, and retrieval systems must be in place for safe extraction. First aid and decontamination. Emergency response must be available in case of injury or exposure. 5. Training and compliance. Employee and contractor training. Workers must be trained in hazard recognition, PPE use, and rescue procedures. Incident reporting. All near misses and accidents must be documented and investigated. Proper personal protective equipment is essential for protecting workers from hazardous atmospheres, falls, chemical exposure, and other workplace risks. Selecting the right PPE ensures safety and compliance during confined space work. 1. Respiratory protection. Workers must wear proper respiratory protection based on air quality conditions. Air purifying respirators, used when contaminants are present but oxygen levels are safe. Supplied air respirators, required in oxygen-deficient or toxic environments where clean air must be supplied. Self-contained breathing apparatus provides an independent air supply for high-risk spaces. 2. Fall protection and retrieval. 4. Vertical entries in confined spaces. Fall protection is critical. Full body harnesses required for restricted or elevated entry points. Lifelines and lanyards connect workers to retrieval systems for safe extraction. Tripods and winches essential for non-entry rescue operations. 3. Chemical and skin protection. Workers exposed to chemicals or hazardous substances need proper protection. Chemical-resistant suits and gloves. Prevent contact with harmful liquids, vapors, or biological contaminants. Flame-resistant clothing required in flammable or high-heat areas to prevent burns. Protective footwear, slip-resistant, chemical-resistant, or steel toe boots for enhanced safety. 4. Hearing and eye protection. Hearing protection, earplugs or earmuffs to reduce high noise levels in confined spaces. Eye and face protection, goggles or face shields protect from debris, sparks, and chemical splashes. 5. Head and hand protection. Hard hats prevent head injuries from falling objects or low-clearance spaces. Impact-resistant gloves protect hands from sharp objects, chemicals, and extreme temperatures. 6. PPE maintenance and compliance. Inspect PPE before use. Any damaged or expired equipment must be replaced immediately. Workers must be trained on proper PPE selection, use, and limitations to ensure safety. As we conclude this training, let's take a moment to reinforce the key takeaways for safe confined space entry at Nature Rich Labs. Key takeaways. Always follow permit procedures before entering a confined space, no exceptions. Conduct atmospheric testing before and during entry to detect oxygen levels, toxic gases, and flammable vapors. Use the correct PPE, respirators, harnesses, gloves, and protective clothing help keep workers safe. Maintain clear communication. Entrants, attendants, and supervisors must stay in constant contact. Have an emergency response plan in place. Never enter a confined space without a proper rescue strategy. Training and compliance are ongoing. Safety is everyone's responsibility, and following OSHA and Nature Rich Labs procedures is critical. Final thought. Confined space entry is a serious operation that requires careful planning, the right equipment, and teamwork. By following Nature Rich Labs safety policies, we can prevent injuries, protect lives, and create a safer work environment for everyone. Thank you. We appreciate your commitment to safety and your dedication to following best practices. If you have any questions or need further clarification, please reach out to your supervisor or the safety team.